All right, mixed multiple choice calculator problems. 83, finding a limit. So the first 83, the second 83, 85, and 86 are all finding limits on your calculator. A thing you know how to do, need to know how to do. So let's do the first one. Limit as x approaches infinity of 1 plus x to the power of 1 over x. So regardless of what the function is, you want to type the function what thingy is next to the limit, you want to type that into y1. If you're on an old calculator, make sure that you put that exponent 1 over x in parentheses, otherwise you will get the wrong answer, I promise you. So do that, and then go to second window to go to your table set options, and make sure that independent is set to ask. That's going to allow you to type in specific x values that you want to know the y value of. Now that we've done that, let's go second graph to go to our table. And you should see a screen that says x and y1. Maybe it says more, but it says at least x and y1. And now we want to know the limit as x approaches infinity. So what you should do is start typing in x values and then like increasing and look for a pattern in the y values. So I would start with 1 and you get 2. And then I'll go to 10 and you get 1.271. And then I'm going to go to 100. I'm increasing by a power of 10 each time. So now type in 100 and you get 1.0472. And then type in 1,000 and you get 1.0069. So it looks like we're getting closer and closer to 1. Let's make sure. So now let's do 10,000 and you get 1.0009, so even closer. And now let's do 1 followed by 5 zeros. 1, 2, 3, 4, 5. Oh my gosh, I keep hitting the wrong button. 5 zeros, and hit enter, and why won't it let me hit enter? And hit enter. No, it's still not letting me hit enter. Okay, I don't know what the deal is. Okay, mine's broken. Hold on. I think this is irony. I pressed the wrong button. It brought up my calculator debugger, which like a debugger normally like helps you fix problems. And then when I went back to my calculator, by opening the debugger, it actually froze my calculator. So the debugger actually messed up my calculator. I don't know, whatever. I'm using a calculator on a computer. Anyways, when you type in 1 followed by 5 zeros, which is a number we normally call 100,000, you get 1.0001. So you can see that this number is getting closer and closer and closer to 1. And if you do 1 million, you actually get 1. So this limit is going to be 1. Sweet. Let's go ahead and just do 83, the next 83 at the same time, because it's the same function here, right? We just want the limit as x approaches 0. So I would do like the same thing, except now I'm going to do numbers closer and closer and closer to 0. So I could again start with 1. I know that that's going to give me 2. But then instead of going 10, now I'm going to go 0.1. I'm going to go the opposite direction, get closer and closer to 0. So now it's like I'm dividing by 10 each time. And I get 2.5937, and then I'll go 0.01, getting me closer. And I get 2.7048, and I'll go 0.001. Right? So each time I'm adding a new 0 in front of my 1, and I get 2.7169. 0.0001 gives me 2.7181. Maybe you see where this is going already. 0.00001 gives me 2.7183. And if I did it once more, 0.0000001, 2.7183 again. What is special about that number, 2.7183? Well, that number is E. And so this limit is actually another limit definition of E. We looked before at 1 plus 1 over x to the power of x as x went to infinity. That was also E. So you can see that those are very similar limits, but this one is when you go to 0 you get E. So that's kind of cool. So there you have it. There's 83 and 83, aka 84.